Okay, the last video cut me off, but we got to the point where when we took the derivative and set it equal to 0, we ended up with two factors. This is squared. This is always positive, never 0. This is the only one that, I think we could say it, this is the only one that could be equal to 0. So x would equal 1. If we plug that back into the original function at 1, y is also 1. So the coordinates of the point are 1, 1. Okay? Let me know if you have any questions on that. All right, the next problem. Find the critical coordinates of the critical point here. Well, again, we got to take the derivative. Well, I like to write it, instead of having a negative here, I'm going to put this into the denominator, and I'm going to use the quotient rule, right? Which is f prime g minus f g prime over g squared. Right, so the derivative will be, derivative of x is 1 times this minus x times the derivative of the bottom, which is e to the bx, but also b, I'll do it like this, e to the bx, times b, because that's the derivative of that, over e to the bx squared. Now I'm going to simplify this. There's an e to the bx that I can factor out, and I'm left with 1 minus bx over e to the bx squared, which I'm going to write like this, right? Because those will go away. And this is now the first derivative. Notice, I want to set this equal to 0 to find critical points. This denominator, e to the bx, is a exponential growth function, never 0. So we only need to worry about the numerator. So I'm going to come over here. 1 minus bx equals 0. I'm going to add bx to each side. Divide by b. X equals 1 over b. That's where I have my critical point. In order to find out the coordinates of that point, take this x and I plug it right back in over here. So it would be, let's see, y equals, where an x is 1 over b, times e, or we can, I'll leave it there for a second, minus b times x, which is 1 over b, right? Equals 1 over b times e to the negative 1, which is 1 over b e in the denominator. So our coordinates are 1 over b is my x, and 1 over b times e in the denominator is my y. I hope that makes sense. It's important to look at the different parts of the derivative to say, well, some portions will never be 0, so we don't have to worry about those as we're trying to find the critical points. Okay? Now, we have a surge function here. They're telling us a and b are both positive. So, just like before, we need to go about finding the first derivative. So I will rewrite this as ax over e to the bx. A and b are both positive constants. So I'll use the quotient rule. The derivative of the top is just a times the bottom minus the top times the derivative of the bottom. And we already said the derivative of e to the bx is e to the bx times b, right? So I'll put b e to the bx all over e to the bx squared. I'm going to leave it like that because I'll be able to get rid of it, or simplify it away in a second. There's an e to the bx that I can factor out. I'm left with a. Actually, I can factor out an a too, can't I? So I'm going to put that there. That makes this 1 minus bx, doesn't it? Because the a comes out. All over e to the bx times e to the bx. Wanted to get rid of that. So, my derivative is a 1 minus bx over e to the bx. All right, well, we want to look at this, set it equal to 0.